So while we're waiting out the 5 minutes or so, has anyone got any questions on what we covered the last time around? I mean, the main thrust of the last time around was just the user interface in PixInsight. But anyone got any questions on what we did cover?
Oh, we're good.
I hopefully that is a case of everyone understood it and not that I was just too confusing and don't have any questions.
I think I have a question about the generalized histogram stretch.
Yep.
I think it was you that suggested using the color mode.
Yes, I always use color mode for the first stretch. Stretches after that, mostly in RGB or a specific color channel. But I generally, on my first stretch, the one where you take it from, invisible up to just about where you want it, I almost always do that in color mode to preserve as much color as I can.
Well, I've been trying that over the last month, and I really like the result. It does come out much more colorful, but I'm not sure I understand what's going on. Why is that different from RGB?
It's a different color space. So there's a bunch of different color spaces. There's RGB. There's what is it? Cyan, magenta,
yeah.
whatever.
Yellow. That's the printing. Yeah.
Yeah, and so there's one more color space, which is color, saturation, and luminance. And what they're doing is stretching it and preserving the color channel. It's effectively applied in a different color space, as I understand it. And the net effect is that you actually get control over how much color you include. So you'll notice in GHS, there's a slider under, I don't have GHS in front of me here at the moment, but I think it's under the color combine section there. And you can dial down the color all the way down to what you get just with standard RGB. Or you can boost it way up. When I say that, are you running on a Mac?
No, this is a PC.
Okay, so you will have that slider. I think, Jerry, if I remember.
I'm trying to open it right now, but I'm having a bit of difficulty with my Windows. Yeah. Let's try it.
Just bear with me a minute.
VHS.
If I stop sharing and then share my screen, there we go. Now I should be able to, with a little luck here, pull up. There we are. So if you open GHS,
yeah,
you will see that there is a slider right here that's grayed out at the moment called Color Blend. And if you select color mode, that slider is now usable. And if you slide it all the way down to here, that's the standard you get with RGB, and then you can increase that as you go up. So once you get your stretch right with it all the way over here, if you find some of it is overly saturated, you can dial down that saturation just by dropping this slider down.
Blair,
great. Thank you.
Question about the Mac version of that?
Go ahead, Jerry.
Blair, you had some question about the Mac version of that?
Yeah, once upon a time, I think it was Bob told me he didn't have this slider in the Mac version.
This is in the color mode?
Yeah.
And, well, there's an RGB and then color blend underneath, yeah?
Yeah, okay. No, he had told me he didn't have it.
Okay. Maybe he just wasn't in color.
Could be.
I'm curious, the click box for use RGB color space, is that related to your personal monitor? Is that what they're getting at?
No. 1 second.
Sorry about that.
That's all right. You're talking about this little checkbox right here. This little guy right here? So you can read what the MOSOver says there. It's actually pretty good information on most of the MOSOvers in this. But basically what this does is it uses the come on, get back here. It uses the coefficients from the RGB working space as opposed to the color, saturation, luminance color space. So I'm guessing what it does is it bases the color on the RGB color space if you click that. I've never used it, tell you the truth.
Okay, thanks.
Okay, well, we might as well get started. No one else has joined there. Jerry, while I'm showing this little presentation, it's in full screen mode, so I won't see people wanting to get in. If you would just let them enter, that would be great.
I will do that. Yeah.
Okay. So before I bore everybody to tears, rehashing something that most people know, is anyone here, now I know, Glenn, you're not real familiar with some of the stuff that goes on in calibration, but is everybody familiar with what goes on when you calibrate an image, what a dark frame does, what a flat frame does, that sort of thing?
Reasonably.
Okay. I will go through this because I know Glenn would like the information. I'll go through it quickly, and if anyone's got any questions, you included, Glenn, just shout them out, and we'll go through them in a little more detail. So the idea is that I wanted to go over quickly what is actually in an image and what we're doing when we calibrate and stack in PixInsight. And I thought it might be good to take a look at what is actually in the image so you can understand what's going on when we're trying to get rid of it with calibration. So if we take a look, there's obviously the image data. It's the only thing we want in the image. All the other stuff we want to get rid of. And speaking of the other stuff, there's a dark signal. Now, a dark signal is basically not related to the light collected, but it is a signal that builds up in the pixel over time, and it's temperature dependent. So if I expose for, pick a number, 10 minutes, I get a certain number of electrons in the pixel that are due to dark current. They're not due to the image at all. And we don't want those. We want to get rid of those. And we'll talk about how we do that here in a minute. But it is proportional to integration time, the exposure, and it's temperature dependent. This is the main reason we cool cameras, is to cut this dark current down. We would like to make it 0, but if anyone can find a way of doing that, you'll get rich. There's a bias signal. Now, the bias signal is caused by two things. I'm pointing at my screen again. I'm sorry, that doesn't do any good. This bias signal is caused by two things. There's an intentional pedestal that's added to the data, and it's done to prevent negative numbers coming out of the analog to digital converters. Most of the time, the ADCs we use are not signed, and they will do one of two things. They will either clip at 0, leaving you with artifacts, or even worse, they will wrap around and become a big positive number. That happens because in binary representation, in order to make a negative number, you flip all the 1s to 0 and all the 0s to 1 in the positive number, and then you add 1 to the result of that to get a negative number. So what happens is 1, 1, 1, 1, 1, 1, 1, however many bits you have in your camera, is -1. So if you have even a small negative number, it looks like a really big positive number in unsigned math. So that's why the pedestal here is added in. There's also classical bias data, which is caused by the bias currents within the sensor. And also noise from those bias currents. It's in all other frames. So this bias signal is in your darks, it's in your lights, and it's in your flats. and it is important that it be removed because it prevents proper flat fielding. And we'll take a look at that in a little bit. There's also optical aberrations such as vignetting, and if you have my camera, dust bunnies, lots and lots and lots of dust bunnies. And we use flat frames to take those out as well. And there's also noise. Noise is random variations in all of the above, including the image data. There's not a whole lot we can do about that one, but the rest we can control to some extent. So there's a couple of myths about modern cameras, in particular CMOS cameras, that I wanted to quickly go over, just to put them aside so that people know that they're not really true. So one of them is that, and this is a little bit of technical mumbo jumbo, and I got another slide coming up to show you what this is, but double correlated sampling removes bias. It's a bunch of people who should know better have even done videos on the fact that it removes the bias. It does not remove bias. As a matter of fact, we have to intentionally add a bias in so that this system works. Another thing that people tend to say with modern cameras is darks aren't necessary. Now, you can get away without darks. However, dark current builds up at different rates in different pixels. And although it's not strictly a noise, it is something you can remove with a dark frame, and we'll look at that. And this is another one that irks me all the time, is someone will tell you mono cameras are automatically better. Nothing against mono cameras. They're actually very nice. I had one once upon a time, but they're not better. They're not worse either. Give you an idea. I don't know if anyone is familiar with Jason Dane. He's another club member here. But Jason and I were fortunate enough that I had a color version of his mono camera. Jason had an ASI 2600 Pro MM version, and I had the MC version. So we both photographed the same target for the same amount of time, and then started looking at the SNRs that were achieved. And surprisingly enough, the mono camera, you can see the SNR and dB here. Now, I should point out that if the SNR is not different than about 3 dB, it's effectively the same. You're dealing with noise, and a 3 dB variation in noise is statistically irrelevant. So typically, if I see an SNR that is, like, if this one is 40 and the other camera is 43, they're the same. Really doesn't matter at that point. You
Blair?
can see the one. Yeah,
I'm sorry, may I ask a question?
absolutely.
Were the telescopes that were used for the to run these cameras, were they the same optical system?
Not only were they the same optical system, they were the same telescope.
Oh, awesome, cool. Okay, cool, very good. Thank you.
Both Jason and I have Skywatcher Spree 120s, but both cameras were run on Jason's setup.
Okay, thank you.
So you can see here, the mono camera had approximately 40 to 41 dB. The color camera had 41 to 44 dB, and the only channel that has even a slight statistical difference is the green channel at 44 dB versus 41. For all intents and purposes, those two cameras are producing exactly the same image. The difference is that if you had seeing that was superb, in theory, you get double the resolution out of the mono camera. I don't know about the rest of the people attending tonight, but if I get 1.5 to 2 arc seconds of seeing, I'm jumping up and down and saying, "Oh my God, the air is steady." Living on the East Coast, that would be a very good night. And so as a result, if you had the seeing that you get on top of Mauna Kea or, in Atacama in Chile, then by all means the mono camera might have a little bit better resolution than the color camera. That's a function of the Bayer matrix. If you can picture the Bayer, I don't have a slide for it, but the Bayer matrix will chop out every second red pixel and every second blue pixel, and you use interpolation to get that data back. So effectively, though, you can see the SNR in the channels here is for all intents and purposes identical to what's here, and the exposure times, total exposure times here are not the same. The one-shot color camera was, I got to remember now, I think this was about 2 hours and this was 4 and a bit hours. I say 4 and a bit hours because Jason had to capture the luminance channel, then each of the color channels separately, so it took longer, but the actual luminance exposures were effectively the same. And as a result, like I said, those two images are identical. So there was no real difference between the color and the mono camera using the same sensor. Now, if it's a color camera using an old 8-bit sensor and a mono camera using a new, Sony 16-bit sensor, yeah, there's going to be a difference, but it's not due to mono versus color. It's due to a modern sensor versus an old one. Double correlated sampling. I just want to quickly go through this because you will find all sorts of stuff on the internet about how it removes bias, and you don't have to use bias in your processing. Here's the actual pixel, this photodiode. So what happens is, again, I'm going to use 10 minutes. For a 10-minute exposure, we're integrating light in this photodiode, and it's generating electrons in the diode. Those electrons are transferred to a sample and hold capacitor to generate a voltage. The capacitor is used to convert the charge, i.e. the electrons, to an output voltage, and that's sampled by the ADC. The problem when you do that is each time you sample, you have to reset this capacitor, and the reset level is slightly different. Now, that is the old-fashioned definition of bias. Double correlated sampling gets rid of that difference. What it does is this has integrated for 10 minutes, and then right before you transfer the charge to the sample and hold capacitor, you reset the sample and hold capacitor, and you sample it. You get a number. By the way, this is using an ADC to do the double correlated sampling. You can also use an op amp and do it in the analog world, just coming right out here. Then what happens is this switch closes, and we actually transfer the data from the photodiode to the sample and hold capacitor. Then we sample it again and use the ADC to convert it. So you can see what happens here. Here's reset. During the time reset is high, the photodiode is collecting data. Reset comes low. Shortly after that, this signal B tells the ADC to do a conversion. And when it does, it's grabbing the data that is just the sort of leftover charge buildup in the capacitor. Then you drive this switch with A, and then you sample it again. Then what you do is this nifty little bit of math right here. You take S2 plus a pedestal minus S1. So sample 2 minus sample 1. I'm ignoring the pedestal temporarily. And what that does is it removes this offset due to the capacitor having a slightly different charge each time you reset it. So it removes that. But you notice what you had to do to make sure you don't get a negative result. You have to add a pedestal back in. So double correlated sampling, although it removes what people think of as classical bias signal, the charge that was left over here, you intentionally have to add a pedestal in. So you put a bias back in. It does not remove a bias. So you have to account for that in your processing. If you don't, your flats won't work properly. Fortunately, this pedestal here is in every frame you take. It's in your dark frames, your light frames, and your flat frames. So, and your flat darks, more importantly. So when we calibrate, we end up removing this. So in calibration, dark frames will remove the signal due to the dark current that we just talked about. Bias frames remove the bias signal. Now, the bias frame is also in the dark frame. So most people, myself included, don't use bias frames. There's no problem if you do, but since it's already in your dark frames, why do it twice? What would happen if you used bias? It would subtract it from the dark frame, it would subtract it from the light frame, subtract it from the flats, and then it would do a normal calibration. So, but since it's already there, it will cancel out and you don't have to worry about it. Flat frames remove vignetting, it removes dust bunnies, and if you're doing anything that requires very accurate measurements, it removes most of the pixel to pixel sensitivity variations. And if you're doing things like light curves for variable stars or looking at exoplanet transits, this is exceedingly important. If one pixel is slightly more sensitive, let's say 2% more sensitive than another pixel, and the star drifts from pixel A to pixel B, then you're going to see that star brighten by about 2% unless you properly calibrate with good quality flat frames. Give you an idea, 2% is about the dip of a typical exoplanet. So, you would lose that dip entirely just by not flat fielding properly. So it's something to keep in mind. Here's a dark frame. Now, when people look at this, they immediately say, ooh, that's got all sorts of noise. That's not noise. There's very little noise in this dark frame. This dark frame is an average of 32 dark frames, each one 10 minutes. So the noise is quite low. What you see here as noise, aside from a little bit of amp glow, by the way, this was my Canon 60DA. What looks like noise is actually hot pixels. So what happens is this pixel right here, this bright one, is a little more sensitive to dark current than the black area around it. This pattern is not random. Noise is random. Because it's not random, we can subtract it off. It's in every image we take. So when you look at a dark frame, you're not really subtracting out noise from your image. You're removing this variation. By the way, this dark frame is heavily stretched. You're removing this variation in pixel sensitivity to dark current. As far as what's in a dark frame, it's got a couple of components. One is obviously the current signal that varies with temperature, and it's mostly repeatable. And it also likely varies pixel to pixel. Emma. As you saw from this, there's a pixel to pixel variation as you go across the frame there. There's bias data from a bias frame, which we're at this point actually going to leave in there because it will cancel out in the rest of the processing. There's amp glow, as you saw in that dark frame that I showed you right down in the corner. I'll pull that back up just in case I didn't point it out. This is amp glow right here. It's not an electrical signal. It's actually infrared light generated by the on-chip charge amplifier. And the charge amplifier is located down at the bottom corner of this particular sensor. And the slight glow shows up in dark frames. And one of the things a dark frame will remove, of course, is this amp glow. And there's a noise term that's equal to the square root of the total number of dark current electrons. That's typical of any camera and you can do nothing about it. It's going to be there. The only thing you can do is reduce the amount of dark current, which is why we cool cameras. Here's a flat frame. This was a flat frame of my current setup with my ASI 2600 MC Pro. It was probably about a year after I got the camera, and you notice there's a very few dust bunnies showing up. If you look at that same frame now, it's covered in dust bunnies. I really have to clean the sensor, but I take the attitude of, as long as flat frames will correct it, I won't take the camera apart to clean it. As soon as flat frames stop correcting it, then I'll take it apart. Don't fix it if it ain't broke, in other words. In a flat frame, we have optical aberrations such as vignetting. And you can see that here. You notice this flat frame is darker at the edges than it is in the middle. Shadows from dust bunnies. My frame is mostly shadows from dust bunnies. There's pixel to pixel sensitivity changes. Some of those pixels are ever so slightly brighter than others. And there's dark frame data from the flat exposure. Now, typically that's quite small because flat frames are very short exposures. For instance, when I expose my flat frames using a filter, like an L-enhance or something like that, I'll typically shoot 4 seconds. With my camera, 4 seconds, there's virtually no dark current. I get one dark current electron, according to the manufacturer, every 20 minutes when I cool it to -10. Now, I dispute that a little bit because there is definitely a change in the histogram. So I think when they say there's no dark current, they're really saying after dark current removal on board the chip. There's some, in later cameras, DSLRs and the latest Sony sensors, they have a dark current suppression built in the sensor. And I think they're saying there's no dark current after that suppression. I certainly see evidence of some dark current. The histogram doesn't shift. The peak is still right where the bias peak is, but the histogram gets a little wider. Here's calibration. So in calibration, we try and remove most of the stuff that we don't want from our images. So we remove dark current, we remove bias signal, optical aberrations, and I want to point this out to everybody. You cannot remove noise. Calibration will make noise worse. It does not make it better. The reason for that most people think it removes noise is what we talked about with the dark frame. That signal you saw is not noise. That's a repeatable pixel to pixel dark current sensitivity variation. And noise is totally random. So when you go through the typical calibration sequence, which is right here, you have a raw image, you subtract a dark frame from it. Remember that this dark frame contains the bias, so it also removes the bias from the raw image. You have a flat frame, and you subtract a flat dark frame from it. That removes the bias from the flat frame. And you must remove the bias from the flat frame, otherwise the math doesn't work. Because what you really want, you want the raw image divided by the flat frame. You do not want the raw image divided by the flat frame plus bias. Mathematically, those aren't the same. And if you've done calibration and it seems like it didn't take out all the vignetting, or it overcorrected and you have a dark center and light toward the outer edge, that's because you have bias left in your flat frame and you didn't properly calibrate your flat. You either have to subtract the bias or, generally speaking, just take flat darks and subtract them. Flat darks are so fast to take because, even with a filter in a modern camera, you're only looking at, assuming you're using a flat panel, you're only looking at 4 seconds. So you can shoot 32 flats in a matter of minutes. Image noise. So noise is a random variation in a signal. And I can't emphasize the word random enough. If the signal is not random, then it can be removed through simple subtraction or division. And it is not noise for the purposes of this discussion. So when you looked at those flat frames, the reduction of signal at the corners, that's not noise. It's not random. It occurs in every frame. Same, excuse me, I got the hiccups. Same with the dark frame. All that speckle noise that you saw is not noise. It's dark signal, and you can remove it because it's repeatable. If it wasn't repeatable, i.e. noise, even when you subtract 2 frames, you add the noises. Well, you add them in an RMS fashion, square root the sum of the squares. So as a result, noise must be random. And if it's not random, then it's not noise and you can remove it in calibration. And noise is very much the key in what we're trying to do in calibration, right? It places a limit on what we can do in follow-on processing. When you've got hours and hours of exposure and you have a nice quiet image, you can bring out faint details that you just can't bring out when it's noisy. Noise reduces with the square root of the total exposure time. So if you have a single frame and your single frame is, let's say, 5 minutes, and then you shoot 5 of them, now you've got a total of 25 minutes of exposure, and the noise of that single frame is reduced by the square root of 25, which is 5. You reduced it by a factor of 5, which is a big change. And it's better to take lots of sub-exposures than a single long one. Now, I know most people here know that, but I thought I'd just emphasize it a bit. It's easier to track and guide for short exposures than a long time. Wind, planes, and as of lately, satellites only ruin one short portion of the image, unless a Starlink trail goes by and you lose a whole whack of images. But anyway, that's what some of the combined modes we'll look at tonight take care of for you. And short exposures should be sky limited. What I mean by that is the noise should be photon noise from the sky. Now, an image, any shot you take, the light itself has noise. It's inherent. It's a quantum property, and you can't get rid of it. And it's equal to the square root of the number of photons that you receive. And you want that to place the limit on your noise for your image, not your camera noise. So that just means you have to expose long enough that this photon noise is about 5 times the camera read noise. And that will take care of that for you. There's lots of online calculators for calculating that. Any questions before we move on to actually calibrating in PixInsight?
The batch processing script has some options, checkboxes that I know were confusing me, and I was doing it incorrectly for a while, and I think you attempted to get me on the right track, but I know there's something confusing about that, but I don't have it in front of me as to what the options are that you shouldn't click on.
We'll go through that as we look at the weighted batch pre-processing script, Jerry.
Okay.
I think I know the exact one you're talking about. It was something to do with optimizing darks.
Yeah. Now,
Yeah.
Juliana has also asked in the chat, how do you take effective flats for a fisheye lens?
Juliana, the simplest way to take a flat, there are two very simple ways. One is to use a flat panel, which goes across the whole lens. That tends to work reasonably well. The other one is to shoot your flats in the daytime on a cloudy day with a white, doesn't really have to be white, but effectively a white cloth over the front of the lens. Both of those will help, but there are limitations on what you can do with flat fielding. So if your fisheye lens produces enough vignetting that you get, 20% drop in level, then you might be able to fix that with flats, but it's going to generate noise because it's going to, when you do the division by the flat frame, it's going to boost the noise at the edges of the image. So there is no perfect correction that you're going to get, but you can get a decent flat with a white cloth over the lens shooting a cloudy sky. Better yet, use a flat panel. They're a little more repeatable.
So what I'm trying to say is that the fisheye lens is different than, taking pictures with,
Yes,
it's slightly different. It's inherently slightly different. You know what I mean? More challenging to correct.
yes, it is.
So
The thing about a fisheye lens is all of the light is not on axis. That tends to cause problems with light panels. So it depends on how wide angle your fisheye lens is, but that can cause you some issues. So if it does, then it might be time to look at doing, we used to call them t-shirt flats, where you shoot a cloudy sky with a white cloth over the lens. That may produce better results.
Yeah, thank you.
And as I said, if the fisheye lens vignettes enough over the whole wide field that the edges are dropping by 20% or more, which is not impossible, then that's going to start to generate noise at the edges, and you're probably going to have to crop it a bit.
Mm-hmm. Yeah, thank you.
You're welcome.
How fussy do you have to be about keeping the optical path absolutely the same between your image and the flats? For example, if you want to rotate the camera, do you have to take a whole new set of flats every time you do another rotation of the camera?
The short answer is, if you have dust bunnies on your camera, then yes. If you don't have dust bunnies, and you have very good optics so that the vignetting is symmetrical, then you can get away with it.
If the dust bunnies rotate with the camera, though, shouldn't that be okay?
It won't be okay if you are combining with previous night's data.
Oh.
So you should take flats for the night in question. If for example, I do this quite frequently, and I just wrote some software to do it for me automatically, but I shoot a galaxy and it might only be up for, a few hours a year because it moves behind a tree in my yard. And I'll shoot the few hours that year and then shoot a few hours the next year. I will never get the camera rotation exactly the same. As a result, I have to shoot flats both nights.
Well, the difficulty I'm having is that if I do several targets in a night and rotate the camera between targets to get, the framing nice, it's very difficult to also take a set of flats for each rotation.
If you don't have any dust bunnies, you can probably get away with that without too much difficulty. I'm trying to think. The dust bunnies will rotate for both the lights and the flats in that example. The one catch, and it depends on how your focuser works. Are you rotating just the camera?
Yes, just the camera where it's attached to the back end of the telescope.
Okay, but are you doing that through a rotating ring that's attached to the focuser, or are you doing that by loosening the screw and rotating the camera?
Both.
Okay, the reason I ask that is if it's a rotating ring, those are threaded. And when you loosen the thread, you're changing the focus position ever so slightly.
It's designed to be a parfocal rotator.
Okay. In that case, you might get away with it. If you don't have, as long as you have symmetrical vignetting, you might get away with it. If your optics don't symmetrically vignette, i.e., there's a little more vignetting, how can I put that? If you have a square sensor and you have symmetrical optics, then the flat should work. If your sensor, however, is rectangular, you will have a little more vignetting at the sides than you have at the top. And that might cause you some grief. You just simply have to try it and see. My take on that would be, first off, try it and see. If it works, great. But the night that you try it, do you have a light panel?
Well, I have a light panel that works on my smaller refractor, but I don't have anything for my larger 8-inch Schmidt-Cassegrain. And that's the one that's a problem. The only way I have of doing flats is to do it in the daytime.
Yeah.
And if I often don't even keep my equipment all assembled.
Yeah, I know what you mean. The short answer is try it and see.
Yeah. Okay.
That sounds like a stupid answer, but that is the best answer. That's the best approach to take. I could tell you that it would work, and for some optics it will. For other optics, it might not. So try it and see. You don't lose anything by trying it, because if it doesn't work, you're going to shoot flats the next day anyway. That's what it amounts to, right? The biggest thing is make sure that focus is parfocal all the time. And if you loosen a screw and rotate the camera, make sure the camera doesn't move out or in a little bit. That could, depending on how fast your optics are, screw your flats royally.
Okay, thank you.
Yeah, fast optics are harder to get good flat correction. Any other questions? Okay, well, let's move on to PixInsight and the weighted batch pre-processing script. Now, there are two stacking scripts in PixInsight. One is fast batch pre-processing. The other one is weighted batch pre-processing. I'm going to go over and cover the weighted batch pre-processing tonight. Fast batch pre-processing is a subset of those operations. Everything we're going to talk about tonight applies equally to fast batch pre-processing, with the exception of a few checkboxes that don't exist. So we open up the script. So here is the script as it starts. Now, I'm going to do a manual load of a bunch of images. I'll get into another way of doing that and point out some of the gotchas a little later. But I better turn off grouping keywords here. Bear with me. So very first thing you're going to want to do, you're going to want to load your files in. So for instance, if you want to open up some light files, now bear with me. I had a bunch on my desktop here all set to go. And of course, my desktop seems to have disappeared. There we go. So we'll just take night one here, and we'll take some lights. So here are a couple of light frames. I'm only going to use 4 because weighted batch pre-processing takes a while to run. You select them, add them in. You're going to do the same for your flats. And again, just select them and add them in. And you're going to do the same for your darks. Now, there are 2 sets of darks here. There's the darks for those light frames, and there's the darks for my flats. And I've got them both in here. I have master darks. I have a dark library that I use over and over again. And I'm just going to load both of those up if I select it here. You will see from the file name that there's a 4-second dark and there is a 900-second dark. My lights were 15-minute exposures, that's this dark, and my flats were 4-second exposures, that's this dark. I have to load them both up. So now I have my darks loaded, my flats loaded, and my lights loaded. And I want to go over something here, especially with, it's not on flats, or yeah, darks and lights. You will notice this exposure tolerance. If your camera software doesn't have a very good tolerance on your dark frames or even your light frames, it's not impossible that it would vary by a second or two. So, I'm shooting 15 minutes, maybe one is 15 minutes and 1 second, another one is 15 minutes and 2 seconds, another one might be, 14 minutes and 59 seconds. Some camera software has that kind of variability. That's what this exposure tolerance is meant to cover. So if you've got a 2 or 3 second exposure tolerance in your darks, lights, or flats, in each of the individual tabs, I believe except for the flats, correct, you will find this exposure tolerance. Set it high enough to cover the variation you have in your frames. Otherwise, they won't get summed in. They will get summed together as separate images, which is a bit of a pain. So in the case of my camera, my exposure times are all spot on, so I usually leave that at 0. But just keep in mind that if you start finding a bunch of rejected frames, and PixInsight will tell you that it's rejected some frames, it could be simply that your exposure tolerance is too tight. And you can vary that by whatever's required to make it work. You'll see it's on the light frames as well. Calibration exposure tolerance. I typically have mine set to 10 seconds. I think that's the default. You could dial it down to 0 with my camera if you want it. We have the Calibration tab, and this is where you make sure that everything lines up. So if I come to my flats, now I'll ask a question here. The folks that are attending tonight, are you using mono cameras or one-shot color cameras? Or a mix of both?
I'm using mono.
I'm using color exclusively.
Okay. So
Mono. I use a mix of both.
Fair enough. So
For dark sky, color.
Go ahead, Susan.
I said for dark sky, I use color, but for planetary or solar, I'll use a mono camera.
Okay. If you are using a color camera, check this box. It's color filter array. It tells PixInsight that it's basically a bare matrix for that frame. So for instance, you select flat frame right here. Select, in my case, CFA, and then apply to all flat frames. If it's a mono camera, you don't have to do this step. You can then see the calibration diagram here. So you can see here's your flat frame, you're subtracting a dark from it, and that produces your calibrated flat. You notice dark is set to auto. Auto will try and line up the exposure of the dark frame, 4 seconds, to the exposure of the flat frame, which is also 4 seconds. Remember the exposure tolerances we talked about. If your dark frame is 5 seconds, it won't match it unless you've got the exposure tolerances set properly. Got to do the same for the light frames. So again, in my case, they're color filter arrays. Now, one thing to watch out for, my camera control software does not put a fits keyword in to describe the mosaic pattern, whether it's RGGB or any of the other patterns. Because it's not there as a fits keyword, I have to select it. If your camera software puts it in, auto will work. If your camera software does not put it in, do not count on auto working. So it's always safer to select this just to make sure. Debayer method, there's a couple of different debayer methods available for people using color cameras. There's bilinear, there's variable number of gradients, which I heavily suggest you use. It is much better than bilinear. And there's superpixel, which combines all the pixels into one. So I almost always select VNG. Again, apply that to all light frames. And you can show the calibration diagram. And now you can see that I have a light frame. I'm going to subtract my master dark frame. I'm going to divide by my master flat frame. And that gives me my calibrated light frame out. Always check this calibration diagram before you press run, because especially if you're using the load directory, which we'll take a look at a little later, some of the files may not match up and you may not be getting the calibration you expect. So it's always worth checking that before you tell it to run. I turn on automatic cosmetic correction. All that's going to do is if I've got some hot pixels with a sigma higher than 10, it will nuke them. You can reduce that if you've got hot pixels, you can dial whatever sigma you want. 10 usually works for me, so I don't worry about it too much. Up here under the calibration settings for the light frames, the possibilities are auto. Generally speaking, auto works. What it does is it looks for a dark frame that's got the same exposure as your light frame within the exposure tolerances that you've set. Flat frames, in this case, I only have one flat, so it's pretty straightforward. So auto will work fine for that. Now, this optimize master dark, that was something Jerry just asked about. First off, if you have a CMOS camera, it's a little bit of a waste. You can't optimize CMOS darks the way you can CCD darks. What this used to do, Jerry, was if your darks were not quite at the same temperature, you subtract off the bias, which is what this does, and then with the bias removed, you can scale your dark for temperature. So you, in a CCD camera, doesn't work for a CMOS camera, unfortunately. But at any rate, it used to let you basically take one dark at one temperature and use it for everything. So you can optimize your master dark by removing the bias, and then what will happen is it will, PixInsight will scale that optimized bias removed dark to match the temperature of your lights. That doesn't work so well with CMOS cameras these days. The other thing it screws up is it can cause you some problems in flat fielding. You have to make sure that the dark that's applied to your flat is also optimized. You have to remove the bias from it. That, Jerry, was what was causing you grief with those images that you had the vignetting in. So unless you have an older CCD camera, I would leave that unchecked. And in order to do that, you of course have to load a bias frame.
But you haven't loaded any biases yet.
I haven't loaded any biases yet, so checking that is a moot point. I don't tend to use bias in my processing because it's included in the darks, and I shoot flat darks. So as a result, it's not really necessary for me to load up a bias. Because it's in all the frames, it's automatically subtracted. Next thing
hurt
here,
if you add your own bias frames, does it hurt?
I wouldn't think so, Jerry. It's just a bit of a waste, simply because it's the only time shooting a bias makes any sense is if you don't shoot flat darks. Then the bias gets removed from the flats, the bias gets removed from the dark and from the light, and then all the calibration still works. But if you have flat darks, you do not want to use a bias.
So you don't want to, or it doesn't help that much?
It hurts. You do not want to shoot flat darks and use biases. That's bad news.
It's one or the other.
It's one or the other.
Okay. Blair,
Yes, ma'am.
I was just wondering, how dark are your skies if you can take 15-minute light subframe?
When I am taking 15-minute subframes, that is with a filter. So that is with an L-enhance or that sort of thing. However, having said that, my skies are Bortle 7. They're definitely urban skies. And I can easily shoot an unfiltered 10-minute sub.
Wow.
The latest round of ASI cameras, I use a Zoo ASI 2600 MC Pro. And it is no problem in the middle of a city shooting a 10-minute sub.
Wow. Sorry, which brand, which model was it?
It's the ASI 2600 MC Pro.
Okay.
Most of the Zoo cameras that use Sony chips are pretty good. They have a really wide dynamic range, and I have absolutely no problem shooting 10-minute subs. I could probably shoot 15-minute subs unfiltered, but I like a little more star color. I lose too many, I'll saturate a few too many stars.
Yeah.
That's the only reason I back off on exposure.
Okay. It's good to know. Thank you.
So we looked at the calibration settings. The next one is the output pedestal settings. What this does, again, when integer math is used internally, and it can in some instances be used, this adds a pedestal in. I generally leave it as automatic, and it calculates what the pedestal should be. It places a limit on the pedestal of this value. So basically, that is the bias that will be added during calibration to prevent negative values. It seems so strange that they put that in because most of the math is done in floating point and negative values are perfectly acceptable, provided you scale them back to 0 at the end. But at any rate, that adds a pedestal in. Cosmetic correction we just looked at, that will remove hot and cold pixels. I have never messed around with using a template. You can take darks and get a template. I tend to find the automatic selection seems to work pretty good, and I don't have problems with hot or cold pixels just simply by selecting automatic. We looked at the CFA settings. Come on, mouse, get over here. A couple of other things of interest in this particular dialog. I'm not using grouping keywords yet. We'll get into that. But down in the global options, I generally detect masters from path. It also detects them if you check that from name. So if it sees the word master in the name, it knows it's a master frame. And I save groups on exit. Those are just the defaults that show up anyway. You can purge the cache before running unless you are redoing something that you had already done. So for instance, let's say you calibrated 15 images and then you shot some more the next night. Don't purge the cache because it will use those calibrated images from the previous night and add the new ones to it. So basically, if you have no use for the cache, purge it, but otherwise just leave it. Up here, this button can be quite interesting. This lets you set the quality of the calculations, not the quality of the image, although obviously the maximum quality with no compromises can produce the best image. Susan, are you trying to say something there? You muted.
Where did you click to bring that up?
I clicked select right here.
Oh, select. Okay. Presets. I now see it. Okay.
So you can select this and set it for maximum quality here, which I almost always use. And you can select it faster with lower quality. It will run much faster. Yeah. But this fast level here is pretty much supplanted by fast integration now. If you look up under scripting, you will find a fast batch processing that does effectively the same thing, even a little faster still. This is faster with good quality. I don't know about the rest of you, but typically when I come home at night, I'll go to bed, I'll get up in the morning, and after I've had coffee, I'll load a bunch of images into PixInsight, press the run button, and then go away and do whatever it is I have to do for the day. It will take a while, but I just don't care, so I leave it on maximum quality almost all of the time. Post-calibration really is where you can set up exposure tolerances between groups of images. So suppose I have some images where I have a 10-minute exposure, and then I have another group of the same thing with 7-minute exposures. And I wanted to add them all together. You accomplish that by setting the exposure tolerance here. So you would set this, in the case of 7 minutes and 10 minutes, you'd set this to 3 minutes. The time is in seconds, by the way. If you have a color camera, you can set the channels configuration, and you can do combined RGB processing. You can do separate RGB processing. This will separate out the color data and leave you with a red image, a green image, and a blue image, which you then have to combine. And you can do combined and separate, which will leave you with a red image, a green image, and a blue image, plus an RGB image. I don't really see any difference in the quality of the final result, so I just generally leave it on combined RGB. If your camera is such that you get a definite quality improvement by processing the channels individually, by all means do separate. And if you want both, you can have both. Keeping in mind, of course, that if you separate them, it takes longer to run because it's got to process the red channel, the green channel, and the blue channel separately. Finally, we have drizzle configuration here. If you enable drizzle, you can change the scaling of your image. So I can upsample effectively by 2. In other words, double the resolution. It only works well for undersampled images. If your images are not undersampled, do not expect a great change in resolution. Generally speaking, I've done some reading that says it's a good idea to drizzle at a scale of 1, even if your images are properly sampled. However, having said that, personally, I don't notice any difference. So I generally don't do drizzle processing unless I want to up the number of pixels in my image, thinking I'm getting better resolution when I don't. Now, if I shoot with my DSLR and a camera lens rather than my telescope, then my images are undersampled, and then drizzle is a good idea. It will improve the resolution. If your image is already oversampled, you're not going to improve the resolution with drizzle.
What's your feeling for SeeStars?
I have a comment about that. I have a SeeStar S30, and because it dithers automatically all the time, it's continually shifting by a small amount where the picture is being taken. Drizzling actually works extremely well. The SeeStar has a very small sensor chip with fairly low resolution.
And a short focal length, so it is undersampled.
Mm-hmm.
Yeah.
So
that is what drizzle's built for.
Great success with doubling the resolution by drizzle.
That is what the drizzle algorithm was originally designed to do. Take an undersampled image and improve the resolution, provided you have lots of images. I've seen all sorts of definitions of what lots is, but certainly 16 or better-ish.
Well, again, with the SeeStar, it's designed to take hundreds of very short exposure images.
Yeah. And it also dithers in between them and you need dithered images to get anything out of drizzle processing. So a SeeStar is actually a very good candidate, as is a DSLR and camera lens combination on something like a star tracker. If you put the DSLR on a big telescope, then all of a sudden you are oversampled and drizzle's not going to do anything. Any other questions on what's on the post-calibration tab? Finally, there's the pipeline tab, and it's basically just a list of here's what it's going to do. At which point you can click run. I'm not going to just yet. And it would go away and calibrate those images. So it'll subtract. You can see we go to the calibration tab. It will take the darks off. It will take a dark off the flat and then divide the dark corrected flat into your images, producing a properly calibrated image. Then it will star align them. It will stack them. It'll do all sorts of fun stuff with, if you look here, it will correct any linear defects. So if you've got a CCD camera that produces, if you've got a bad row or column of pixels, it will help take that out. It'll debayer the images if they're color images. It'll make a bunch of measurements and decide whether or not the frame is bad and reject it. Again, your exposure tolerances, if you find you have a bunch of rejected frames, blink the frames. You could literally have some bad frames, but you can also have frames of different exposures and your tolerances are not set well enough to have the weighted batch pre-processing script know that it should stack them all together. It will then pick a reference frame, and if I remember correctly, reference frame selection is set by, is it in this one? Oh, it's fixed now. Okay. I think it's set by SNR, if I remember correctly, so it picks the best SNR image. And, oops, back to the pipeline here. Once that's done, it will register the images, so that's star alignment. It will do local normalization. So what this is doing, your images may all be really good, but sorry, Susan, are you trying to say something there?
I was just going to comment that you wouldn't check linear defects correction unless you actually knew you had linear defects in your camera's sensor.
That is correct. You can check it off here.
However, uncheck it, yes.
Or uncheck it, yes. However, what you can also do is it will go through and it will look for linear defects. If it doesn't find any, it won't do anything.
Right.
But it takes time to do that. Not a huge amount of time, so I generally don't worry about it because, like I said, I go away and finish my coffee and my breakfast. Okay. So you can leave it checked. It won't cause any harm, but you are correct. If you don't have linear defects and you uncheck that, it will process a little bit faster. Yeah. The more subs you have, however, that little bit faster might make a big difference. So Richard, in your example of processing hundreds of frames from a SeeStar, if you don't have any linear defects, it might be wise to uncheck that. It will run a little bit faster. But local normalization is actually a very nice function, and it's one of the things that you give up when you go to fast batch processing. Local normalization, if you can picture, you have a bunch of different frames, they might have a different sky background. Now, what I mean by that is some of the frames may be a little lighter, some of them may be a little darker, maybe the moon was just setting, who knows what. Local normalization will try and normalize the background in all of the frames to the same level. It, of course, normalizes the brightness of the object as well. The nice part about that is you don't get one bright frame swamping the background of all of the other frames that way. So it's actually a very nice capability. It is unfortunately one of the slowest parts of the processing, but it's well worth doing in the weighted batch pre-processing script. It is, however, definitely one of those functions where you want to go away and have coffee, maybe breakfast. If you're doing hundreds of images, maybe dinner as well, before that finishes. But it is worth doing. Then it will integrate all those images. It will do an auto crop. If you've turned it on, and I'll show you where all these are turned on in just a minute, it will also do an Astrometric Solution. And depending how you've configured this, if it can't solve it, it will fall back and ask you to play around with the settings to manually do an Astrometric Solution. If you go to the Lights tab, that's where most of these final items are selected. So you can turn linear defects on and off here. You can turn subframe weighting on and off and select what you want for subframe weighting. So you can weight your subframes by signal weight, point spread function signal weight, point spread function SNR, point spread function scale SNR, a total SNR estimate, or a weighting formula. Generally speaking, I leave it at the default, which is PSF signal weight. Sometimes I will select PSF SNR weight. Generally speaking, I like SNR weighting, and they give you a good definition of what each of those is in the, oops, come on. I guess I can't do that. I have to hold it on there. In the MOS over help. And they tell you, which one will work for what. What this is going to do is it's going to generate signal weightings when you average your data. And let's say I have 30 frames and one frame is a little noisier than all the others. It will weight that noisy frame less in the average. That means it won't degrade the image as much. Now, when the SNR differs by a lot, and a lot is not that much, if you get an SNR that's differing by 5 dB, maybe 3 dB, this can make that image weight so low that you might as well not integrate that frame. It basically just almost sets the weight to zero. It sets them via the SNR. So if I've got one image that's got a 10 dB poorer SNR than all the other images, its weight will be very close to zero. You can do frame selection. I never turn that on, but if you set it up here, you can configure the rejection criteria. So for instance, I can set it up to reject stars with certain full width half maximums, certain eccentricities, certain median values, all sorts of stuff.
Blair, the interactive version of that is really powerful.
It is. However, the reason I don't tend to use that is I tend to use Blur Exterminator. And Blur Exterminator actually, because it uses a variable point spread function that can vary across the image, it's designed to take most of that stuff out. So if your stars are slightly trailed, it'll fix it. If your stars are a little big in some frames and not in others, it'll fix it. So I don't tend to leave that function on. There's nothing wrong with leaving it on and throwing away those frames. But I tend, because as I said, I use Blur Exterminator and it fixes it after the fact, I can still get a little bit better, especially if I only have a few frames. I can get a little improvement in SNR by allowing those frames. So I just don't tend to use it. That's my preference. If others have different preferences, no problem. Just click it, select the setup icon here, and set what you want to reject. Keep in mind,
in my experience, the SeeStar images should be culled somewhat.
Fair enough. I don't tend to get large star trails with my Celestron mount and Esprit. They tend to be, if anything, a couple of pixels. So it really doesn't do anything for me. But you are right. If they're long enough, then Blur Exterminator is not going to fix them. And at that point, you may want to cull them. The one note I will mention is when it rejects a frame, it doesn't just reject the bad part of the frame, it rejects the whole frame. So just keep that in mind, that you are potentially throwing away some good data if you use that. If the stars across the whole image are trailed, then what does it matter?
I've had some success with the interactive version of this.
Yeah, that's what Jerry had just mentioned.
But you have to be careful if you're going to leave that on interactive, don't walk away and have breakfast.
Exactly.
Because it will pop up the interaction screen and just sit there waiting for you to do something.
Exactly. Yeah. Image registration. This is going to, at this point, align all of the stars in the image. And again, you can select your pixel interpolation and a whole bunch of stuff through here. The MOSovers, again, are pretty good for describing what that is doing. They're very, very similar to the quantities that you set for what's the name of the script? The Astrometric Solution. So they're very similar to that. Just click that. We come down to local normalization. Again, you can do it interactive. I don't tend to use interactive for it. And you can set a couple of parameters, like reference frame generation, how you're going to generate it, what PSF type to use. I almost always leave auto. And a matter of fact, I almost always leave these at the defaults. I've never had to play with them that much at all. Image integration. This one I do play with. And so you have a couple of different combine modes. You can take the average, the median, the minimum, and the maximum. Generally speaking, average produces the best SNR result. Median is about 3 dB off average. Minimum and maximum are really used for outlier cases. So for instance, suppose you have a bunch of frames where pixels are at 0 and you don't want that, you could set it to take the maximum, keeping in mind that's going to produce a lower SNR, but you won't have black dots in your image either. Now, rejection algorithm, there's a variety of them. Most people select auto. I don't tend to. I tend to use Winsorized Sigma clipping almost exclusively. And the reason I do that is I'm going to try and be polite and say, I dislike Starlink trails in my images. By using Winsorized Sigma clipping and greatly reducing the high sigma, you'll notice I've got it set to 1. Sometimes I'm even lower than 1. I think the default is something like 3 to 5. Matter of fact, we should be able to, one sec, reset to factory defaults. It doesn't change it. But at any rate, by reducing the high sigma, and you have to play a bit with this. It's not something that you'll get right on the first shot. But I generally have this dialed down close to 1, and it completely eliminates satellite trails. To the point where I don't bother using any of the functions that are available from SETI Astro to remove images with trails. This just takes care of them for me. What it will do, and it takes care of them for me where it only removes the data from the satellite trail. It doesn't remove the rest of the data from the image. So I still get all the SNR improvement, and I get rid of the satellite trails. If you leave it at its default value, I generally find there's a faint trail left, and the more I stretch the image, the more annoying it gets. That's a function of not having this high sigma set low enough. So you can dial that down until that goes away. Large scale pixel rejection, I generally leave high selected. Again, it helps in removing some of those satellite trails. But I do play with those values from time to time. And it is well worth, if you've got an image that has some satellite trails, it's well worth playing with the high sigma value for Windsorized sigma clipping. It will virtually eliminate your satellite trail problem. I've got NGC 4565, and I had 630 satellite trails in the image when I just did a straight average. I just wanted to see how many were there. And when I did Windsorized sigma clipping and dialed this down, I actually had to go a little bit below 1 to get rid of them all. I had a perfect image at the end, no trails at all. So it's definitely worth playing with that. If you have data where you have hundreds of images, it costs you a lot of time to play with that. So what you might want to do is take 4 or 5 images that have different satellite trails and play around with those until you get a value that works, and then try stacking your whole set. That might save you a lot of wasted time. But once that's set properly, you don't really worry too much about Starlink. Anything else that we haven't covered here yet? So that was image integration. Astrometric Solution is pretty straightforward. Here, this information is read from the FITS header. If your software does not put that information in, it will default to the manual or interactive mode. However, you can come in and key that information in here, and then it might not default to interactive, and it'll do it all for you within the script. Any questions so far? Susan, were you saying anything there? You're muted. No? Okay. Now, one item that I definitely want to demonstrate to people, you may already use this, and I'm just going to reset everything here and remove all of the images. Okay, so now we're back to an empty script. Does anyone use the load directory function? I know Jerry does. He's shaking his head vehemently. For those that don't, this is an absolute godsend. However, you have to have software that produces all of the right FITS keywords to make it work. One of the things that I found out just recently is PixInsight does not look at your file structure to determine files. So if your imaging software produces a subdirectory called lights and it puts all the light frames in there, PixInsight couldn't care less. PixInsight looks at the file type keyword in the header of each file to determine the type. And as a result, if your software puts them all in the lights directory, but doesn't set the keyword to light, it won't stack properly. So make sure your software does set all that up properly before using the directory import. Directory import really works well if you use grouping keywords. Now, if you're like me, especially when I'm imaging from the city during a work night, I don't have work nights anymore. I'm retired now, but when I had work nights, this comes in quite handy because I can make a keyword called night. And if we look at the directory that I'm going to load, the Cygnus wall, you'll notice there's night_1, night_2. You could just as well have the date in there if you wanted, so it could be night and the date. But what that does, night is the keyword, the underscore is the separator, and what comes after the underscore is the data that it's going to use. So for instance, this in each of these subdirectories, I have darks, flats, and lights. The darks are the same. I have a dark library, but I did load them for purposes of demonstration here. I loaded them into each of these subdirectories. But I have all of my lights here. 1 second. I'm going to open up File Explorer so I can show you that a little better. So if we look at the Cygnus wall and I go into night 1, you'll see here's all my flats. I only loaded up 4. There are 32 of them in the actual directory. And here are my lights. Again, I only loaded up 4 or 5, but there are like 30 or so in the actual subdirectory. Appropriate keyword, it will take the flats from night 1 and correct the lights from night 1 and use the darks from night 1 as well. And it really saves you having to set up a whole bunch of images. The catch is when you take your flats data, one of the keywords that it sorts all the files by is the filter name. So if you're shooting light frames with a red filter, as an example, then you better have the same red filter in your flats, at least in the file header. Otherwise, it won't use those flats. So I had to go in with my flats because what I had done, I didn't shoot the flats using the same schedule that I was using for the lights, and I should have. I simply loaded up another schedule, a generic one called flats that I use whenever I shoot my flats. And of course, I didn't have the filter selected in it. So it didn't use any of the flats, and it pissed me off because it took 3 hours to combine all the images, and they weren't flat corrected. So at any rate, cautionary note, make sure that if you're using a filter, even though your flats are shot with the same filter, make sure you select that filter in your imaging program so that it will put the keyword in the fits file. But having said all that, if I now click directory, and if I go to the Cygnus wall directory, and I only have to go to the root directory, and I click select folder, it will go away and load all the files, and you'll notice they're all in the right spots. Here are all my dark files. There are 2 15-minute dark files, 1 for each night. In actual fact, they're both the same because they come from my dark library. There are 2 4-second dark files that are my flat darks. I have flats, 1 for my L Synergy filter and another batch for my L Extreme filter. And I have light frames, L Synergy filter and L Extreme filter. And it loaded them all up correctly. It's all set to go. All I have to do is hit run. So I don't have to go and rearrange everything. So for instance, I better show you one thing. What I do have to do, since I have a color camera, I have to tell it that that is a CFA image, and I have to do the same for my lights. And I set my mosaic pattern because my camera does not, or my camera software does not put a keyword in for that. You can just click run and away it goes. And you can see, you can look through here and see that everything for night 2 is all lined up. It's RGGB. I'm going to use VNG as my debayering algorithm. There you can go through each of the settings, and you can see it's going to use the appropriate dark frame, the appropriate flat frame. There are no biases used, and I'm not optimizing my dark frames. I just click run and let it do its thing. I will click run. It may take a few minutes here. It will give you a few warnings. One is always cannot create files with path names longer than 256 characters. I don't worry about that. And like I said, we can let this run. I probably won't let it run until it finishes because it will take a little bit. But just to give you an idea, it'll run through and do its thing. The ones that will probably take the longest will be the local normalization. What this will do, this will produce 2 output files. One will be for the L Synergy filter. one will be for the L extreme filter, and then I can take those and combine them however I choose for a narrowband image. Any questions? Silence?
I
Okay.
guess I have a question, but not sure if it's related direct to processing, but where's the cutoff? You kind of made it sound like more frames are better, but at the same time, from the camera's perspective, you like to be sky limited. Do you play that game, or do you just have your favorites 10 minutes and so you use 10 minutes?
I did a bunch of experimenting with my camera when I first got it, and I settled on 10-minute subs for unfiltered frames and 15-minute subs for filtered frames. I did all of the math before I went out to do the exposures. From dark skies, a sky limited, when I say dark skies, what is St. Croix, Jerry? Bortle 4?
I'm not sure.
I think it's Bortle 4. But at any rate, so that's the Halifax Center Observatory. When I go out there, reasonably dark skies, and I settled on 15-minute filtered shots and 10-minute unfiltered shots. I did the math and have sky limited subs. I generally said, okay, but if I do that, then I've got almost three times the number of sub exposures. And when I shoot a 10-minute sub, I don't have too many saturated stars, so why not shoot the 10-minute sub? The downside is I get more satellite trails, but as we just discussed, Windsorized Sigma clipping will fix those. My mount tracks well enough and guides well enough that I don't worry about. I think since I got the mount that I'm using now, I have not thrown away a single sub exposed 7 years. So it tracks well enough that I just don't have a problem. If I had tracking problems, I'd be shooting shorter subs, but I don't, so I just shoot 10-minute subs.
Okay, thanks.
You can see this is now doing the LN reference generation, and then it will do local normalization. Take a look at how long this is going to take. All of the others are measured in fractions of a second, except for debayering, which took 13 seconds for all of the images. And this one is already up over a minute. So you can see that these functions, reference generation and local normalization, they do take a while. They'll probably take on this in the neighborhood of 2-3 minutes. So I will shut this down eventually, but you get the idea that it'll just keep running and doing its thing, and eventually it would produce those two output files. Any other questions so far?
Blair, I have a question.
Okay.
Do you solve part of your
That basically
calibration?
gives you a good. Go ahead.
Do you also play solve part of your calibration?
Sorry, say that again.
Do you also play
Right down here,
solve?
Astrometric Solution.
I cannot say anything.
This is the plate
Hear
solve
me?
right here. Yes, I can. Can you hear me okay?
Yes. Do you also
Can you hear me,
play?
Juliana? Okay.
Yes. I think we have a delay, and sometimes you break up, Blair, just to let you know. From where I am in
Okay.
Windsor, you break up. Do you play solve when you calibrate, or you do not? I don't see play solving here.
Yes, I do, and I do it with this script. You notice right down here, Astrometric Solution?
Oh, okay. It's
that is the plate solve.
okay. Thank you.
I have a question.
Go ahead.
I haven't done it in a while, but did they change WBPP so that the autocrop is done actually physically done before the astrometric solution is calculated? Because
Yes, they have.
Oh, they have. Okay, because it's been a while. Haven't used it in a little while.
Yeah, the order,
So,
you can see the order of operations right
right,
here, and you notice there's an autocrop and then the
right.
Astrometric Solution.
Okay, I'm just making sure that it actually represents the true order. Like they could show it that way,
does.
but
Yeah,
okay, cool, very
does.
good. I'm glad they fixed that finally.
Yeah, that was annoying in some of the earlier versions where it would
Yeah,
do the plate solve and then do an autocrop, which would nuke the plate solve.
that's right. Yeah, thank you.
Okay, so I'm going to halt this, and the reason I'm going to halt it is I have the final result of this image as part of what we can look at here. How are we doing on time? Okay, we got about 30 minutes. So what this would do, if I had let it finish, it would produce two images, which I would then combine, and I tend to combine them manually. There are lots of really simple palette choices that you can make. And I'll, 1 second here. And I have already made this image. So here's the final image. This is an SHO palette. And I took the stars out of the SHO palette and I took the stars from the effectively HOOL extreme filter and put those in simply because I don't like the color of SHO stars. No other reason. So this is the final image. You can see here it is with no screen stretch. Here it is with a screen stretch. And first thing I would do with this, and we discussed this last time around, is after I do all of the linear processing, so I would run it through, this has been run through, by the way, all the linear processing that we showed last week. So there's blur exterminator, color calibration. I think I had a little gradient that I removed, and then I ran it through noise exterminator. That produced this particular image. So this has been linearly processed. Then today I ran Star Exterminator on it and produced two images, which I'll call N and S. Open those up. So here's my star image, and here is my nebula image. Now, the problem with this nebula image is the color is a little weak. You could turn saturation up, but it's still not quite what I want in my final image. So what I'd like to do here, I'll go through how I get the color I want in that image using GHS. It's a good tutorial on GHS itself and some of the uses you can use that particular stretch system for. So we'll open up GHS here, Generalized Hyperbolic Stretch. And the first thing I want to do, I want to stretch this image and get as much color in it as I can. So just before I do, we'll set a symmetry point somewhere around here probably. And I'm stretching in color mode, as you can see. I've left the color blend all the way up. And it's a good example here of what this will do for us. I better turn preview on and turn the screen stretch off. Now, as we stretch this, you can see the image is yucky and green, but you also notice it's saturated around this area. Okay, I can turn down the saturation with this color blend. You see what that's doing? So that's what this color blend does for you. You can dial the saturation down if your image is oversaturated. And we will change the local intensity a bit here just to get sort of the beginnings of an image that we want. There we go. That's not too bad there. And we'll just up the contrast ever so slightly here. There we go. So there's a reasonable first stretch of the Great Wall. But you will notice that it's predominantly green because, of course, it's predominantly H alpha, and that's in the green channel. And it's not looking like a classic Hubble palette image yet. So we're going to apply that. And bear with me a second, I have to reset everything here now. And now we're going to work on the color. So the first thing I'm going to do is I'm going to see, I have 3 histograms here. The red one, the blue one, and the green one, which is buried in amongst the others there. First thing I'm going to do, I'm going to line the red histogram up with the blue, and I'm going to stretch just the red histogram. So first thing I'm going to do is stretch red, and I would like this area in here to be a little redder, to say the least. So I'm just going to click in there to set my symmetry point. And then we're going to stretch it. You notice it's starting to get redder. You see the red starting to show up in here? Okay, and we will play a bit with that. And we'll apply that. Now the problem is, oh, I lucked out. If they're not, you notice the histograms are not quite lined up. So now what I want to do, I want to align those histograms. I will go to linear mode instead of GHS. Now I have the classic black point and white point sliders. I'm only going to mess with the black point. And I'm going to align, oops, I got to select red, sorry. I'm going to align the red channel. So that it's centered with the blue channel. Okay. Now, you can do a couple of iterations of that, bringing out more and more red in the areas you might want. Next thing I have to do, though, I have to align the green histogram. So again, we'll go to green. You notice the green is quite a bit higher than the red or the blue. All I'm doing is aligning the peaks. So again, since all I want to do is shift it, I'm going to go to linear mode. And we're going to drop the green down. Now you can see this is starting to look a little more like a classic SHO palette. But I still want a little more red in the image, so we're going to stretch the red again. And I'm just going to do this iteratively a couple of times. Now I'm going to stretch the red a little more in the dimmer areas, so we'll set the symmetry point to one of the dimmer areas, and we'll stretch it. Ooh, a little too much. Now you can see you're getting red all in this area. Red is sulfur emission, by the way. And we'll just turn up the local intensity a little bit. Oops. Try that again. There we go. And then finally, if I apply that, now I still have to realign my red histogram again. So for that, I use linear mode and just move the black point. Also helps if you select the red channel. There we go. And all I'm going to do is line up the histogram. Need a little less sensitivity. There. What did that do? There we go. So now you can see you've got something that's almost a classic SHO palette now. And you can play around a bit. You can stretch the blue a little bit to take out some of the green. Oop, not green, blue. Generalized hyperbolic stretch. And we'll just stretch it a little bit. You don't have to go crazy here. And then once we do that, we'll align the blue channel one more time here. So I'm using linear mode to align the channels. There we go. So now you can see you're starting to get a little more blue from the O3 in this area now. You've got good sulfur emission through here, and the wall itself has definitely got lots of sulfur emission. And then finally, we can up the saturation a little bit. Right about there. So there we have an SHO palette that was kind of a real yucky, only green before. And now we've got some red from the sulfur. We've got O3 emissions up here. And we've got lots of emission from hydrogen alpha, which is the green. Then we can take the stars and add those in quite easily. Once I apply that. So you can see here's my nebula image now. Now we have to take the stars and stretch them. We'll zoom in a bit. We don't have to zoom in for that. And generalized hyperbolic stretch. Again, the first stretch in color mode to retain lots of star color. There. Turn off the screen stretch. And just dial up my stars until they're about where I want them. Now I'm just going to zoom in here a bit. I got a little saturation clipping there. I might be able to take that down a bit. Let me see. By turning down the highlights a bit. Whoops, did I just click on? Sorry about that. Something's wrong. Try that again. There we are. And again, go to color. And I've got a little saturation clipping there, so I'm going to dial that down here just a little bit. That's got most of it gone, and I have reasonably colorful stars. We can fix up any clipping in the brighter areas of the image. And then let's look at what my stars are going to look like. So here's what I have for stars. Click OK, and then we will turn the saturation up just a little bit. That's probably overdone, but let's just see what it ends up looking like. And then we'll combine those two images. I may not have enough stars here just yet to make the image look normal. If I don't, we'll just stretch it a little further. And generally when I come, there's all sorts of different combination routines to use, but I generally use this one because it doesn't clip anything. Now the N S. And oops, that's not the button I wanted. This is, and we will create a new image as opposed to overwriting any. Oops, what didn't it like? It doesn't like N. Oh, identifier N. And I probably have to set this identifier to S as well. There we go. So here we have an image. And I would probably put a few more stars in compared to what I have there. And some of the stars are a little green. You notice this star right here? That's a little green for my taste. I could take that out. Yeah, it's even green here. So what we could do, if we stretch that to put a few more stars in, it's not going to take much of a stretch now. One sec. There's a few more stars. But we don't want green stars. So the simplest way to fix that is to use, under noise reduction, SNCR. And SNCR will remove the green from the stars for the most part. There we go. So now we have reasonable stars with no green. And now we can recombine that image, and we should have more stars, and they should not be green. There we go. So here's our final image. I haven't done any sharpening or any of the other stuff that I would do. I'm just giving you an idea of what you can do with GHS on a narrowband palette. But you can see now we have a reasonable SHO image. There are lots of ways of producing an SHO image. One way that works quite well, I have to, 1 second here, find my original image. Here we are. Here's my original image. There's a script from SETI Astro called Perfect Palette Picker. And it works quite well. The problem I have with it, oh, okay, I have to load my original images. Sorry, I can't do that here. The problem I would have with this particular script from SETI Astro is it applies a stretch to the image, and it's not necessarily the stretch I want. I end up stars than I like. They're a little bloated. What I would have to do here, by the way, is load up my original dual band HA03 image and my sulfur 03 image, and it will then produce all of these palettes. And then you just pick the one you want by clicking on it, click exit, and you've got an image ready for additional processing. As I said, the only reason I don't tend to do that is the stars get a little bigger than I like. They tend to bloat a little bit. You can play with the color in this image. You know, if you find it to be too green, you can just dial down some of the green as an example. You can do it with GHS as well, but SNCR or SCNR rather works well for that sort of thing. And here you have a Hubble palette image.
So Blair, so you
Yes.
don't need to color calibrate here because it's a Hubble palette, isn't it?
It is a narrowband image, so
Yeah.
color calibration.
Narrowband too. Yeah.
Yeah.
Mm-hmm.
Yeah.
Okay.
Yeah, that's the reason I didn't do color calibration on this image.
Mm-hmm.
Any questions? Well, it looks like we finished up almost right on time tonight. Okay, again, if anyone has any questions that they come up with, feel free to shoot me an email. I sent my email out to everyone, so feel free to fire me any questions that you've got, and we can work through them.
I presume this will be saved as a video online.
Yeah, it'll take me a couple of days probably to put it up, and I went through last time and put sort of chapter markers for all the sections, so I'll try and do that again. I think it helps to be able to jump back in when you've forgotten some part and you want to go back and find that part.
Very useful. Thank you.
Thank you, Blair.
You're more than welcome.
I just
Thanks so
realized
much,
how
Blair.
much you have to learn.
Good enough.
Thanks.
Okay,
Great, Blair,
hopefully, Glenn, that'll help you with. Hopefully, Glenn, that'll help you with moving over to PixInsight to stack your images.
It'll get me started for sure.
You know where I live, and when you have questions.
Yeah, absolutely. Don't expect miracles.
Fair enough.
Thank you.
Okay. Good night, everybody.
Thank
you, Blair. Good night.
Right.
Good night. Stop sharing. Here we go. Thanks again, Jerry, for all the help getting that set up.
Okay, good. We'll get it processed. Maybe not this weekend, but
Yeah, thank you, Jerry.
Something about a bunch of Nova East stuff to get done.
yeah, and it's going to be warm tomorrow, so who knows?
There's a lot of
and it's going to be clear starting Saturday.
yeah. There's a lot of background, behind the scenes work involved in terms of getting getting the video posted on YouTube and all this kind of stuff.
Oh yeah, yeah.
So, and that's much appreciated. That's a lot of work.
No problem. I think my Final Cut Pro now comes with automatic text or voice to text. So
Oh, cool. That's good.
we'll have to go through and edit that and get the spelling of RASC correct and such, right?
Well, in that case, Susan, he should have it up in what, an hour and a half, 2 hours tops?
Well,
Sure.
the meeting took an hour and a half for it to do the processing of just the audio to text. So
Yeah.
Yeah.
Wow. Anyways, good night, guys. Thank you.
okay, good night.
Right.
Take care.